I'm going to talk a few minutes about some of the work we're doing in my lab relative to the challenges of biodiversity conservation in Alberta. And in particular, as Jay was mentioning, rapid changes in land use, climate change, other things that threaten our natural heritage, our biota. One of the primary challenges that you hear in the media quite a bit, both locally and of course international attention, is the oil sands. The map on the left is the oil sands, the bitumen deposits. The darker colors in the red and maroon are deeper deposits. Some of these deposits are close enough to the surface to allow open surface pit mining, and that receives quite a bit of attention. But I argue from a terrestrial biodiversity standpoint, our greater threat in the future is the in situ. So that region represents 142,000 square kilometers of bitumen deposit. Only 3% of that is close enough to the surface to be mined through open pit mining. 97% of that has the potential of in situ mining. So with in situ mining, they're drilling wells instead, and it changes the landscape in a different way. It may relate to only about a 10% loss in total habitat, but there's a tremendous amount of fragmentation that's associated with that type of mining. This is an example image of one of these leases. You'll note here, the first thing that is done is seismic lines are first cut through the forest on a grid. Oftentimes, in some places, these are on 100-meter or even less spatial pattern. And these are used to essentially map out the reserve, the bitumen reserve, to know the depths and for drilling. Next follows the well pads and infrastructure and pipelines and other type of activities that are used to extract and move bitumen. The issue with this is this changes the landscape. This changes the boreal forest tremendously. You have winners and losers, and in fact, one of the major issues is these seismic lines and other linear features increase movement of organisms. In some cases, that is to the detriment of some species like woodland caribou. So here, these seismic lines increase primary prey for wolves, so moose, deer, they increase in abundance. The primary predator of moose and deer being the gray wolves also increase. And it turns out that the seismic lines and other linear features also allow greater permeability and movement of wolves. And that increases the chance that wolves bump into caribou. Caribou numbers are quite low, and with increased predation rates from wolves, caribou populations have been declining dramatically. As a response to that, Environment Canada, they've been classified as a threatened species under the Species at Risk Act. With that, there's been a recovery strategy, and the recovery strategy has identified to leave 65% of caribou range in Alberta as undisturbed. And what they define as undisturbed is anything that's further than 500 meters from a human footprint or disturbance. So you'd basically take this entire landscape you're seeing in this image, and remember those seismic lines are about 100 meters apart, a 500-meter buffer on all of those. So essentially you're seeing in the boreal forest that there is very few areas of undisturbed habitat for caribou. That has created a great challenge because if they establish a threshold of 65%, something has to be done to recover habitat. One of those is restoration or reclamation. So there has to be some way of recovering these seismic lines. I have a student, Cassidy Van Rensen, who is working on identifying patterns of recovery, of restoration of seismic lines, and approaches for reclamating those. So the image on the right here is an example of silvicultural techniques of basically increasing microsites, mounding the soil, reducing compaction. This is typically used in the forest industry, but we're trying to find ways to increase establishment and growth of trees on many of these seismic lines that are not recovering. Her study area represents a small area of the oil sands in the in situ region and is southwest of Fort McMurray in the Stony Mountain area. In that area, there's, in the broader area of the Stony Mountain, there's 12,000 kilometers of seismic lines. In the sub-study area that she's working on, approximately 1,300 kilometers of seismic lines are unrecovered. So they're in a form of arrested succession. They're not recruiting trees and growth and facilitating the movement and the changes in the composition of the boreal forest. The restoration techniques are expensive, however, about $4,000 per kilometer to restore these seismic lines. So in her small study area, that would be almost $5 million to restore habitats of this, for woodland caribou. Well, that's quite a challenge, and probably not something we're going to see those type of investments in conservation. So we have to find a way to identify some areas that are naturally recovering. It doesn't make any sense whatsoever to put $4,000 per kilometer on the few places that will naturally recover itself. So we have to find a way to prioritize the restoration actions given the limited resources we have for restoration and conservation. So the approaches that Cassidy has been using is targeting, an example would be, let's target 50% recovery of seismic lines in this study area. And let's try to consider the fact that some places will naturally recover. Let's consider the fact that let's emphasize caribou zones. So the map in the upper right, labeled A, those polygons are different areas of caribou zones and different levels of priority for conservation, with the yellow and orange areas being the most important. And we should also emphasize the fact that we might as well avoid areas of high bitumen value. So in B, the areas in red there have greater bitumen depth. These are areas that we probably shouldn't put any restoration efforts. They're going to be highly active today and into the future. So we're essentially trying to optimize the location of where we put our research dollars and our conservation dollars for caribou restoration. So in this example, using an optimization algorithm, she was able to find a solution for restoring 50% of the seismic lines for $1.8 million, rather than randomly a cost would be $2.44 million. So more than $500,000 savings in one small area. The second topic I'd like to talk about is, well, we have more than just caribou. We have, our biota is rich in Alberta. If you take a look at some of the other rare species we have, in this case, rare plants, bryophytes, lichens, and butterflies. This map on the right is a hotspot map. Areas in red represent areas of higher biodiversity for rare species. So you'll notice that the mountains in particular, the foothills, some of the grasslands area, many areas of the moraines near Edmonton, all of these areas have fairly high biodiversity. Parts of the boreal forest, less so, but some places such as McClellan Lake up in the oil sands are quite important. Now the challenge is, how do we find the places to best represent and conserve these species? We already have a protected areas network, and that protected areas network represents quite a bit of those species in the mountain parks, wood buffalo, but the protected areas weren't designed necessarily for biodiversity. They were more designed for recreation and tourism. So what we've done here is I've taken that biodiversity hotspot map, and I said, let's protect 10% of all the species. And if you can't protect 10% of those species, where are the most important places in Alberta to meet that goal? So there are, of those 308 species that I've been working with, there are places that they are not represented in these different type of protected areas. The areas in orange and red, the yellows, these are areas that we could consider highly irreplaceable. Those are the places that would best be able to achieve our conservation targets of protecting 10% of Alberta's rare species. So you'll notice areas like the Beaver Hills here, South Saskatchewan, those type of places are quite important, and they're not represented in our current protected areas network. The second point of this is, if there are major developments such as oil sands, we could use these same concepts to identify biodiversity offsets or conservation offsets. So given that there's disturbance in some areas, where could we put some conservation dollars to protect some of Alberta's biodiversity? Third topic I'd like to talk about in the last one is the fact that the world is changing. There's this exogenous factor of climate change. It's not just the land use, and both of those interact and have effects on the persistence and the viability of our biodiversity. So this Quinn Barber, a student of mine, is looking at climate velocity. And this is how fast climate change is moving relative to your ability to keep up with climate change. So in red areas, this represents areas of high climate velocities. What this represents is if you're in the top of the mountain or you're a flat expanse, if the world warms by 3 degrees and you have to maintain your current climate niche or habitat, how fast do you have to move in kilometers per year to keep up with climate change? Well, it's anywhere between 0.1 kilometers to 10 kilometers per year. So areas in red, you have to move 10 kilometers per year just to maintain your original or existing climate niche. Now, it turns out that every place is different. If you're in the mountains, or in the foothills, I should say, you don't have to go very far. You can go upslope. So you either have to migrate to more northern latitudes or to higher altitudes. And so part of this is buffered in terrain, areas of terrain, except for in the top of mountains. Those places they can't necessarily, they're migrating to, they have to make major jumps to different mountaintops. So you'll see the hill systems in the boreal, the grassland areas, and some of the mountaintops in particular are going to be quite sensitive to climate change. Now, if you also consider habitat fragmentation, if the species have to migrate, they have to move through a landscape. So we'd have to understand that land use change as well as climate change and the ability of these species to move to keep up with climate change. So in red, these are areas of high habitat loss and fragmentation, the parkland natural region, some of the grassland natural region of Alberta. These are the most fragmented places. And some of those places are also the places that have the highest climate velocities, creating quite a challenge for species conservation. On the left side is a graph representing a couple hundred rare plants in Alberta, and these are graphed relative to those 2 dimensions, climate velocity and habitat fragmentation. So some species occur in areas of low climate velocity, low habitat fragmentation. We're not necessarily so concerned about them relative to, let's say, climate change and land use changes, at least existing land use changes. But other species, we would be quite concerned about if they're occurring in areas of high habitat fragmentation and high climate velocities. So one of these species I'll pick on is long-leaved bluets, Houstonia longifolia. A rare species in Alberta, only occurs in about 20 locations. It occurs in an area of high habitat fragmentation and high climate velocities, making it quite vulnerable to future climate change. One of the things we're doing is we're taking that particular species, as well as another species in similar habitats called northern blazing star here, and we're using proactive conservation tools to address these kind of challenges for these species by using assisted migration to move these species north. So these point locations are the known populations of northern blazing star and longleaf bluets in Alberta. They're occurring in those areas of high habitat fragmentation and climate velocities, and we're exploring the approaches for assisted migration. With that, I'd just like to acknowledge some personnel in my lab and collaborators. This work is being done under the Alberta Biodiversity Conservation Chairs Program with Alberta Innovates Biosolutions, COSIA, and a number of other partners, looking at the challenges of managing the future of Alberta's biodiversity. Thanks.